Welcome to JDK-9. My name is Alan Bateman. I work in the Java Platform Group in Oracle, long-time JDK contributor. So this session is prepared for JDK-9. So I'm going to start by just a quick poll of the audience, just to see how many people have downloaded and tried JDK-9. Okay, maybe about a third of the people. So for those that put up their hand, how many people tried out their application or libraries and everything worked perfectly? Not too many hands. How many people that put up their hand a few minutes ago tried it and were grumpy for the rest of the day because something broke? Same hands. All right, you're in the right session. This is the list of features that are in JDK-9. This is a screen capture of all the list of JDeps, JDK enhancement proposals, that you'll find on the Open JDK JDK-9 project page. There's a big long list of features. This session is not about all of these features. I will cover a couple of the features, but I'm not going to exhaustively go through all of these features. Instead, I'm going to be mostly talking about the issues that you might run into when you start preparing and thinking about moving to JDK-9. There's a lot of disruptive changes in JDK-9. My colleague Alex Buckley wrote the foreword for the book Java 9 Modularity. And in the foreword, he likened the changes in JDK-9 to be a bit like the tablecloth trick, where you've got cups and plates stacked on the table, and you pull the tablecloth out without disrupting the plates and cups, but in reverse. There's some very deep changes that have gone into JDK-9. So the big challenge is to do the tablecloth trick in reverse without disrupting the cups, the plates, and the heavy power tools that have accumulated on the table over the last 20 years. There are a couple of little breakages, and that's the couple of things I want to talk about today. So this session is actually the first of 5 sessions that we have in the modularity track. We're essentially a track within a track. I'll talk about those later on at the end of the session. So before we get into a few specifics, I just want to talk about just the general compatibility policies. If an application or a library uses supported APIs and works on release N, then it should work on release N+1, even without recompilation. Supported APIs can be removed, but only with advance notice. So let's see how we do on JDK-9 relative to this policy, a compatibility policy that has existed for several years. I'll start with the good news. The class path has not changed. Class loading has not changed. You are not forced to migrate your code to modules. I've read a lot of articles and postings by people that think that you're forced to move and migrate all your existing code to modules in order to move to JDK-9. They are confused. Ignore them. You may have heard of sunmisc unsafe. You may not use it directly in your code, but the chances are some library that you use, that you have on the class path today, is using sunmisc unsafe. It works as before. Most existing code actually just works as before. As we go through this presentation, you'll actually see there really isn't a huge amount of code changes involved. Final point on the good news is all the mainstream IDEs, Maven and all of its plugins, or most of its plugins, they already have support for JDK-9. They're JDK-9 ready, in quotes, by last week when we eventually shipped JDK-9. So that's the good news. The not so good news, which is a nicer way of saying the bad news. You will most likely need to upgrade many of the libraries and the tools that you use. If you're directly using some of the libraries that are shared, some of the APIs that are where there's a version for EE and a version for Java SE, but they're the same library, but they're not exactly in sync. If you're using those directly, you may have to do some adjustments to your build or your class path. I'll talk about that in a few minutes. A number of supported APIs have been removed. They were deprecated some time ago and they were removed. We're talking about 6 methods from the Java SE API, which is not a lot. We removed those right in the first build of JDK9 several years ago. Nobody has complained, so I'm not going to bother covering them in this presentation because obviously people don't really care about them. There's a number of non-API features and some tools have been removed. People have not complained about them, so I'm not going to cover them either because they're not significant things. You will see some warnings, possibly, printed by the runtime because of things that libraries that you're using are doing. I'll talk about that in this presentation. So we'll dive into a couple of items. First is the modules that are shared between Java SE and Java EE. So one of the things about the Java SE and the JDK is that it's assimilated many technologies over the last couple of years. So a bit like the Borg. Some people have likened it to the Borg many years ago, where it assimilated many different cultures and technologies. And while they didn't show it in any episode of Star Trek, I'm pretty sure that the Borg actually had regrets from time to time. The JDK did too. This is the Java SE module graph. If you've been to Java 1 before, if you've seen any of our presentations over the years on modules, you will have seen that we've worked through over the years from a spaghetti diagram to a relatively clean directed graph that you see here. There are many modules in this that originally were standalone technologies. I realize the font is small in there, but if I were to look, I'll easily spot things like Java management. Oh, that includes JMX. That was a standalone technology at one point. I see Java naming. That was JNDI and a standalone technology at one point. What we have up on the right side of the graph is a bunch of modules that overlap with Java EE, and these have not been completely subsumed. So I'm going to start putting a little label. I'm going to use a black star to label these APIs that were never fully subsumed into Java SE, and you'll actually see that these become problematic APIs when you're moving from 8 to 9 because of this overlap. So I've put a black star over 4 APIs that are, 2 of them are really trouble, 2 of them are less trouble, but they have equal problems. Two of these modules bring along a buddy, the Java activation module. It has no business being in Java SE, but it ends up being a standalone technology outside of the JDK and being in the JDK at the same time, like these 4 other modules. Very, very problematic. I'm also going to put a black star against the Corba module. The reason for that is Corba has been our whipping boy for modules for the last number of years. But the real reason, of course, is that Corba is actually dependent on one of these problematic modules. It's dependent on the transaction API, where Java SE defines a subset of this, Java EE defines the full API. And this is a really, really problematic area when you move to modules. So this business of being inside the JDK and outside of the JDK at the same time is essentially technical debt for the JDK. And when you move any big code base to modules, you'll probably run into some technical debt. This possibly is unique to the JDK, but it's still technical debt that we have to somehow figure out. You can't override modules in the JDK by putting jar files on the class path. You can't override modules in the JDK by putting jar files in the endorsed standards override mechanism, because that mechanism has gone. The only way to override modules in the JDK with newer versions is through the upgrade module mechanism, which is a new mechanism in 9, and only if the modules are aligned with the modules that Java SE defines. And this is where we have the problems with each one of these modules. So this is a topic that has been we have been mulling over for a long time, and fundamentally what's happening is the JDK was the delivery vehicle for many of these APIs. It's 2017 now. There's no reason for it to be the delivery vehicle for these APIs. Each of these APIs has a standalone version, and there's no reason why the JDK needs to really have them. So the proposal a long time back in Java SE, which was eventually accepted, was to deprecate each of these modules. And here are the 6. Here's the names of these modules. Java Corba, which is the Corba API and RMI IOP, the Java Transaction API, which is the biggest troublemaker in the lot here, in that because Java SE defines a small subset of the transaction API. Java Activation, because it has no business being in here. Java XML Bind, which is the XML binding API. This may be something that you use directly, or maybe some library that you use. It's probably the most popular one on this list here. Java XML WS, which is the web services, SOAP with attachments, all of that stuff. 2017, kind of legacy now. Java XML WS annotation, which is actually a subset of this API called the Common Annotations that Java EE provides. A subset of that API was defined for Java SE to support web services, and it ended up in Java SE. Now, one thing about these modules is they are deprecated for removal. This is a new form of deprecation that was introduced in Java SE 9. When a module or some other programming element, maybe a class or maybe a particular method, is marked deprecated for removal, it's providing a clear intent that it will be removed at some point. The compiler and the Java language know about methods that and programming elements that are actually deprecated for removal. It knows to give you the right warning, for example. So if you're using any of these, you don't need to panic, and we'll get into some of these things in a few minutes. But let me just show you one other thing that has happened in 9. So they're deprecated for removal, but we have also made one other adjustment which will smooth the path to eventually removing these from Java SE and the JDK. And that change is that we will not resolve these modules by default. Now, you haven't gone to the rest of the modules talks yet, so you don't know what resolution and resolving modules means, but don't worry about that. What it means is essentially, if you're running code on the class path, it will be as if these modules don't exist. It will be as if the types in these modules do not exist. And let me show you an example with JAX-B just to reinforce what this means. So here's a little code fragment using JAX-B's API. I'm calling a static method on JavaX XML bind JAX-B context. This is a static method to get a JAX-B context. Don't worry if you've never used JAX-B, you can just ignore this. The important point is the next, what I want to show you what happens if you attempt to compile this code. You get a compiler error. It will not compile. I'll read out the error. Package JavaX XML bind is not visible. Package JavaX XML bind is declared in module Java XML bind, which is not in the module graph. When I said that the module is not resolved, it's not in this module graph that the runtime has, or sorry, the compiler has and runtime has when it actually starts up and when you're compiling code or running code on the class path. So if you get this error when you're compiling, what happens if I've already got some code that's previously compiled to use these APIs and I try to run it? Shock horror. I get a no class def found error. It's as if I'm missing a jar file on my class path, which is exactly what's going on. So this is a new thing to the JDK. We have never removed modules before, and this is just the first step. And I want to talk about some of the migration options that are around this. This is most certainly a disruptive change, but only for those that are directly using or indirectly using the APIs in these modules. There's a number of migration options, and we've written these up in the JDK migration guide. We have a new command line option, add modules, where you can give it a set of modules that will be additionally resolved at startup. And this is useful as a short-term solution to get existing code that's using these APIs to compile and run. It runs exactly like JDK 8 all the way back to 6 did in the case of this module. So this keeps existing code working, albeit with the inconvenience of adding a command line option. Each of these APIs, except for Corba, has its own standalone version. It has its own JSR that maintains it in the JCP. The artifacts for each one of these modules are published, or jar files I should say, are published in Maven Central. So there's alternative ways of getting these libraries when you use them. And you can deploy those on the class path, or you can deploy them on the upgrade module path. So they're deployed as modules. Now, they're not all quite there yet as modules, but a colleague of mine is sorting it out with the owners of all of these components to make sure that eventually they can all be deployed as modules as well. So that's one big important change in 9, and it's a disruptive change. And I want to move on and talk about strong encapsulation, which for the JDK is all about encapsulating the JDK internals, so that code outside of the modules, these modules, will not be able to get at the classes that are not part of the API, and also so they cannot get at the non-public members of classes that are in the API. So this is a big deal. I'm going to start by going back 20 years. This dusty docs page is from 1996, and I will try to read it unless anyone down the back has brought binoculars and can read it for me. The java.star package make up the official supported public Java interface. The sun.star packages are not part of the supported public Java interface. This is what the documentation said 21 years ago, but no one ever reads these documentation. Now, things dialed up in JDK 6 when Java-C acquired a symbol database. The symbol database was enough for Java-C to be able to print warnings or errors when compiling code that was making use of sun.star APIs or other internal APIs. This acts as a deterrent. So I'm going to pick a little example here of code that has a static reference to Sun Security X509, X500 name. And we'll see what happens when you try to compile this with JDK 6 or 7 or 8. You get a compiler warning. What is the warning? Warning X500 name is internal proprietary API and may be removed in a future release. We all ignore compiler warnings, I'm sure, here. So we've ignored the documentation, we've ignored the compiler warning. Now let's move to JDK 9, where things dial up another little bit. With JDK 9, if you attempt to compile code that's with a direct reference to an internal API, the compilation will fail. End of story. I will read out the error. Package Sun Security X509 is not visible. Package Sun Security X509 is declared in module base, which does not export it to the unnamed module. Now, we don't know what the unnamed module is here because we haven't been to the other sessions, but just assume it's a class path for this presentation. Summary is compiling against internal APIs will now lead to compilation errors in JDK 9. So what about runtime? So this is more complicated at runtime. Oh, I forgot one other thing. JDeps. A very useful tool when preparing for JDK 9 is to run the JDeps tool. The JDeps tool is in JDK 8 and allows you to do a static analysis of your code, your compiled code, to see if it has any references to internal APIs. It's actually a bit of a Swiss Army knife. You can actually get it to look at and analyze all your dependencies. It's a very, very useful tool. Quick poll, actually. How many people here have tried JDeps? Okay, that's better than last year, which is good. So for those that are taking photos, JDeps is JDEPS. So we often get asked in presentations just to spell that out. So I'm going to run JDeps just on that code example I had in the previous slide. And I'm using JDeps-JDK internals, giving it the class. I can give it jar files, you can give it class path. It's actually quite flexible what its input will be. And it's printing out a message to say that my code has a dependency on Sun Security X509, X500 name, and it flags it as an internal API. JDeps has been improved quite a bit in JDK 9. So if you've tried an 8, you'll actually see some improvements in 9. But one of the nice things it has is it has a little table of internal APIs versus supported APIs. So for cases where supported APIs have been introduced and it sees a reference to the old internal API, it'll actually give you a hint. In this case, there's an X500 principal class that was added in 1.4, which is a much better way of dealing with X500 names. Now I want to go back to runtime again and talk about the complexity with runtime. The ultimate goal is to encapsulate all internal APIs at runtime as well. We're not there yet in JDK 9. We attempted to go there in JDK 9. In fact, for over a year, we had early access builds that strongly encapsulated all of the internals at runtime. But a lot of code broke. A lot of code is making use of internal APIs. A lot of code is hacking into non-public members of classes in Java Lang, for example. So what is the story for JDK 9 and runtime now? This is a summary of where things are with JDK 9 now. I'll read this out. All packages that existed in JDK 8 are open to code on the class path. This allows existing hacks to work as before. Now, when I say existing hacks to work before, you will of course have refactoring of internal classes and things that break a lot of these hacks anyways, and that's just part of life. A first, and this is an important point, is the first use of core reflection that makes use that hacks into JDK internals or does what we call an illegal reflective access, and I'll explain that in a few minutes, will emit a warning to standard error. That's a non-suppressible warning. So this is the first time that we've emitted warnings at runtime. The warning, which I'll show on the next slide, is there to create awareness that there is code that will break when the internals are completely encapsulated. The warning attempts to identify what the offending code is and tells you what it's actually trying to access. There is a command line option, -- illegal access, that allows you to debug further. So if you have to debug one of these, you can get additional warnings, you can get stack traces, you can even have it deny access to internals, which allows you to try out what future behavior will be when the JDK fully encapsulates its internals. So I'm going to use an example. I'm using the example of the Jython REPL. By the way, I'm not picking on Jython. I'm just using it as an example. There are many examples I could have chosen. Last year and the previous year, I used examples with Gradle and Glassfish. I decided to give them a break this year. So let's look what the warning is. So this is an executable jar, so it's a java-jar. I get a warning, an illegal reflective access operation has occurred. Illegal reflective access by, and it gives me the type name, it gives me the code base. In this case, it's the jar file with the Jython REPL. And it's trying to access some member of Sun, NIO, CH. This is a selectable channel implementation internals. It's trying to access this. The access will succeed, but you get this warning. And it gives a suggestion about submitting a bug and giving you also a hint as to what command line option you can actually use to get further warnings if you want to investigate it. So this is a new thing, warnings at runtime. Now there's lots of other changes in JDK 9 that I want to talk about. The new version string scheme, JEP 223. You may have heard of this. This is actually quite a disruptive change. I'm not going to spend time going through it. The JEP has all of the motivations for why the old confusing numbering scheme is being replaced with a newer numbering scheme, which is a lot simpler, and I hope people will figure it out, a lot simpler. So here's an example, just a table showing JDK 8 versus JDK 9. These are the 5 system properties that reveal the version. Java version by is the system property that many libraries examine to see what they are running on. So It's nice and simple. And after 20 years, we've essentially dropped the leading one. But that is an extremely disruptive change. I could do an entire session on code examples showing bad code parsing the Java version. We've seen code that thinks it's on JDK 1.1 when it's running on 9. We've seen code that actually tries to execute and load libraries that it hasn't run in more than 10 years. We've seen exceptions, we've seen errors, all sorts of crazy things. There's enough material there for an entire session at the San Francisco Comedy Club. So many libraries have already been working with us over the last few years and have fixed the parsing to be able to deal with 9. But there's probably other code out there. If you maintain any code that is parsing Java version, now is a good time to audit to see whether it'll actually have issues moving from 8 to 9. So a couple of things, features that are in 9 that are actually avoid having to parse the Java version is we have a new runtime version API. So finally you actually have a programmatic way to get the version. Now, this week you'll hear a lot about moving to faster releases and maybe changing the version scheme again. So maybe this API will have to be revisited. But the point is, it's much nicer to be able to use an API to get this information rather than doing your own parsing. We also have multi-release jars, which is something I'm going to talk about later in the presentation. The new binary structure for the JRE and the JDK, JEP 220. This is all about dealing with the moving to a modular platform, because one of the implications of a modular platform is it completely blurs the historical distinction between the JRE and the JDK. This is a disruptive change, and one of the reasons we got this in early in JDK 9, in fact we got it in late 2014, so that the tools and the compilers and the IDEs and those that are actually dependent on the layout on the file system could adjust in advance to deal with this change. So what does this mean? It means that, sorry, I'll show you the legacy structure first, just so you have some idea where we're actually moving from. The JDK, if you download 8.7.6 all the way back to 1.2, where this structure was introduced, you have a JRE directory within the JDK download that has the runtime. There's a lib directory where you have rt.jar. You've probably heard of rt.jar. There's a lib directory at the top level lib directory where you'll find additional jar files. Tools.jar is probably the best known. There are 2 bin directories, one at the top level, one under JRE. They have copies of the same tool. This is an embarrassing accident, the way this layout came about. The lib directory is a hodgepodge of things. It has some files in there that are intended to be edited. They provide configuration, like the management configuration file or security policy file that are intended to be edited. There's a whole bunch of other files in there. You touch them, the JDK is hosed. You're not supposed to edit them. So there was always confusion as to what you should change and what not to change. JDK 9 runtime image format, runtime image, is much simpler. One level, one bin directory with the tools, the Java launcher, Javac, and so on. A conf directory with the user editable configuration file. If it's intended to be edited, it's in that directory. If it's not intended to be edited, it's not there. So what this means is the JRE directory is gone, rt.jar is gone, tools.jar is gone. So this is a big change. Now, I assume most people here won't have code that's too dependent on this, but many of the tools that you use probably do. So that's one of the reasons for having to upgrade your tools. Now, if you go to the module sessions, you'll hear a little bit about the JLink tool and creating your own runtime image. By linking just the modules that you want to create your own runtime. When you use JLink, then you may start becoming familiar with this layout. There's many other changes. I said earlier on that the class path hasn't changed, class loading hasn't changed, but there are actually a couple of changes in this area. The application class loader is no longer an instance of URL class loader. It was never documented as such, but we found many libraries out there that assume this and really want it to be a URL class loader. all of the core modules that where their classes used to be in rt.jar, they're all in modules now. There is no need for a boot class path. So there's some changes there. These are things you probably won't run into too much, but if you've got your own custom class loader and it sets the parent to null, then suddenly the set of types that are visible to it are reduced. So things to be aware of. Nothing to do with modules, but there was a lot of security, defense, and depth work done in JDK9 to move a lot of the non-core libraries and modules away from the bootloader where they've all permissions. They've been moved to the platform class loader or the extension class loader as it used to be. So this is another thing that code creating custom class loaders may actually observe. One of the brave things that was done in JDK9 is to move to the Unicode CLDR locale data by default. Now, this is a really subtle change, but it's a really, really good change. So this is something that has been in preparation for many years. For almost 20 years, the JDK maintained its own locale data. We now call it the legacy JRE locale data. JDK8 was updated to ship with 2 sets of locale data, and there's a system property that you can flip between the 2 of them. It did not change the default. JDK9 switches the default. And this is if you've got applications that are deployed, and I was reading something there recently. Someone was running into some strange formatting of dates issue in I think it was Australian English, and it was a subtle difference between the standardized CLDR and the old JRE locale data. The format was slightly different. It had been updated a couple of years ago in CLDR. So these are little subtle things to be aware of, but what you can do with JDK8 is you can configure to use CLDR, and you can actually observe then in the different locales that you support to see whether you have any differences. JDK9 also took the brave step of switching the default garbage collector to G1, which potentially will change the performance characteristics of some applications. I'm not going into all of these in detail now, just really making you aware of things to think about when you're moving to JDK9. Now what I want to move on to now is just talk about a couple of features in JDK9 that really help with the migration. And I'm picking out 2 of them. JEP 238, multi-release jar files, and JEP 247, compile for older platform versions. I'll start with multi-release jar files. So Java C9 has introduced a whole bunch of new APIs. It has var handles, for example. One of the wonderful things with var handles is you can start replacing some of the code that's using sun, misc, unsafe to use the standard API. But that creates an interesting thing, an interesting problem for those that want to have a library that runs on 7 or 8, and they would like to make use of the new APIs when they're on 9. So that's going to be interesting. How do I get that to work? Another example is the XML catalog API, standard API introduced in 9, and that avoids having to hack into the internals of the XML parser code, which some libraries do. So this is the motivation for multi-release jar files. So what multi-release jar files do is they extend the jar format to allow multiple Java release specific version class files to coexist in the same archive. And I'll show you an example of what this of this in a second. So we'll start with this. This is an example using the jar tool to create a jar file. And I'm going to use the JRTF to just get a table of the contents. This is not new. These are the legacy options that you can specify to the jar tool for the last 20 years. This is how you create a jar file on the command line. This is how you actually get a list of the contents. Now let's add some options to the jar tool, because the jar tool knows about multi-release jars. I've added when I'm creating the jar file --release 9 and -C, and then I'm giving it a completely different directory where I'm going to find some compiled classes for JDK9. And let's look at the contents of the jar file and see what's happened. The jar tool has packaged up these classes and it's put them into a new section in the jar file, which is the versions section. meta-inf/version/ and then the version number. It's put them into versions 9 in this case. If you look closely, you will actually see there are two acme stats CLI helper class files in this jar file, one in the base section, one in the versions section. So this is interesting. I've got classes that I want to use on 9 in this version section. Now, let's suppose I put this jar file on the class path with 8. What classes get loaded? The classes that get loaded are from the base section. JDK8 and older does not know about multi-release jars. It will never attempt to load classes from the meta-inf version 9 section. I put the jar file on the class path with 9, and magically what will happen is the class that's in the version section will override the class in the base section. So this is actually very useful because it means I can ship a library as a multi-release jar, and I can have it use one version of the code when it's on 8 and use newer APIs that are compiled for 9 when I'm running on 9. So this is actually really useful migration aid. However, it introduces complexities because I'm now going to have different source trees, different compile trees, but don't worry about that. There are some good recipes out there. Robert Schulte is talking in one of the other rooms on this topic about Maven and integration with JDK9. I have no idea how they ended up putting us scheduled at the same time, but he is showing an example at this time using Maven and some of the recipes he has for creating multi-release jar files. One other thing I want to actually observe here is that I'm now compiling code for 8. And then I'm going to be compiling classes that are for 9. Does this mean I now end up having 2 JDKs in my build environment? That would be a pain. And this is where the other JEP comes in, 247, compiling to older releases comes in, because it helps you with this problem. Okay, we take questions at the end. So historically, if you were compiling to an old release, you have to specify 3 options. -source, -target, -boot class path. Most people forget the third one. This is why the Java-C compiler has been emitting a warning, I think, since 8 on this, because it creates some really problematic cases. With JDK9, you replace all of this with --release and then the version. You can use JDK9's Java-C to compile to 6, 7, 8, or 9. And Java-C has enough information to know what were the public APIs in 6, 7, 8, and 9, so that if you've got some API and you try to compile it to 7, but that API was introduced in 8, then it'll actually fail the compilation. So it's a really useful thing to be aware of. You combine that with multi-release jars, and you actually have a great solution, a great combination for migration. One other tool I just want to mention is JDeperscan, which is a new tool in JDK9 for doing static analysis like JDeps, and it scans classes for deprecated APIs. And this becomes really important with deprecation for removal, because you want to know that you're making use of something that is marked for removal. If you see Dr. Deprecator walking around the conference, he wears a white coat and a stethoscope, be sure to ask him about JDeperscan, and he'll talk to you about that. So, what can I do to prepare for JDK9? The most important thing is to upgrade the tools and the libraries to versions that support JDK9. In some cases, sadly, this might be a full stack upgrade, especially if you've got older versions, really old versions of some of the tools. If you only take one thing from this session, you will need to upgrade many libraries and tools. And if you do this before you upgrade to JDK9, you will save yourself a lot of frustration. The modules that are shared with Java EE that I listed out earlier in the presentation is really problematic for those that depend on those modules. There's several migration options, and you can figure out what way you want to go. The JDeps tool is really useful to have and be able to analyze your code to see whether it's using any internal APIs. Throughout JDK9, look for illegal reflective access warnings and submit bugs. That's the important thing, so that the code that is doing these naughty things can be addressed by those that maintain that code. If you parse the Java version property, please revisit that code, because the possibility is high that it may not work in 9. And read the release notes. Nobody reads the release notes. JDK9 has 43 pages of release notes, which is probably any problem that you run into you'll actually find a release note will detail that. There's an extreme amount of detail in there. The vast majority of that detail and the issues in those release notes is at the same level of the release notes and the same level of changes that you will see in 7 and 8. How do you prepare for post-JDK9? Why am I talking about post-JDK9? This week you'll be hearing about the proposed new release model, where there's a major release, albeit smaller than what we've done before, every 6 months. This means that things are going to move faster, we hope. It means that we will have an opportunity to finally work through the eventual steps on removing the module shared with Java EE. So that means you will need to figure out how you're going to migrate to the standalone versions. Again, run JDeps, really, really important. There isn't a proposed plan yet how we will eventually encapsulate the APIs at runtime. The warning and allowing code on the class path to continue to hack is what you have in 9, but eventually we want to get to the point where the internals are completely encapsulated. Running with illegal access, I see a typo there, that should be ILLEGAL, of course. Illegal access equals deny allows you to test out future behavior now, because it will deny access. It means a code that tries to do naughty things will get the right illegal access error, illegal access exception, or inaccessible object exceptions. Again, audit your code for the version string, especially if the version string changes again. And test the EA builds. I think this is actually, we found this the most useful thing with 9. The EA builds, early access builds, were available right from the start. Every build was actually published, and that allowed libraries and maintainers to actually work with us from the start and deal with issues. So summary, most code will work on 9 without changes. I've talked about very few changes that actually require code, except for the Java version. JDK9 does include some disruptive changes. I think I've covered most of those changes. And again, make sure you upgrade your tools and libraries in advance to avoid most of the issues. That's the most important message from this presentation. So more information. JDK9 has an OpenJDK has a project, JDK9, and you will see all the JEPs that I showed at the beginning of this presentation. Those JEPs are full of really, really useful information if you have the time to read it. There's a migration guide, which is actually not too bad, that covers most of the main issues that you potentially will run into. There's lots of sessions about JDK9 this week, so try to attend those if you can. Now, just a reminder of our sessions. So myself, Alex Buckley, Mark Reinhold, we have 5 sessions in this room. Alex is doing modular development with JDK9 here at 5:30 this evening. Mark is doing modules in one lesson and migrating to modules in this room tomorrow at 11:30 and 1:15, and then Alex is back on Wednesday at 9:30 to do modules and services. So that's the sessions that I want to plug, because we're a track within a track essentially. Stay connected. There's a DevOps corner that folks here that are working on the JDK will be around over the next few days. There's some links and there as well. Don't believe anything I said, or at least don't buy anything based on anything I said. So that's it. So let's see. We have a minute or two for questions. I don't know whether there's no microphone here, so I will have to repeat your question if so that because we're actually being recorded here.
Yeah. So the question was on the multi-release jar.
You're here.
What happens in Java 10 to that jar file?
Okay, so the question is for this jar file, what happens when I'm on 10? So in this, or 18.3. Okay. So in this case, is assuming there isn't a section that is for 10 or 18.3, then it'll just go to the previous version, which is 9. So in this case, it would load the main class from the base section, and it would load the helper class from the version section. I'm sorry, I didn't quite. Are you talking about the size of the jar file? Yeah. Okay, so I think the question is does the jar file get larger with these additional classes? And yes, it would be, because its size of the jar file is proportional to the number of entries in it. Okay, so the question is for this example, why is the main class not in the version section? So for this particular example, the main class does not have any JDK9 specific code. It's only this helper class that is used for this example. The helper class has the 9 specific code, so there's 2 versions of the helper class. Right, exactly. Someone actually just pointed out it's a bit like overlays and patching.
You mentioned some incompatibility with Java EE modules. Can you expand on that?
Okay, so the question is as I mentioned some incompatibility with the EE modules. So there's you want me to expand on that. So there's a couple of areas. One is the transaction API. That's really problematic. Java SE only defines a small subset of the transaction API. If you look in the JavaX transaction package within Java SE, you'll only see 3 exceptions in there. That's the minimal that's actually required by the Java IDL spec to support the mapping of Corba transaction exceptions to remote exceptions. Another problematic area is the so-called common annotations, where Java SE defines the smallest subset of those annotations to support web services. So they're really problematic areas. So they would be the 2 main problem areas. Okay, so I think the question is about crypto providers. Right, so they should crypto providers, if they're deployed, should work as before. Yes. In addition, the JCE has been updated to be able to support deploying crypto providers as modules as well. Okay, any other questions? Okay, I think we're done. Okay, thank you for attending.